geology to data science?
Yeah, I never expected to end up here. It's quite a surprise to me. I started my career by doing an undergraduate and then PhD in geology. This was back in the UK. I always found geology absolutely fascinating. I loved just finding out more about the world around us and what is out there. And I never thought about doing anything in tech or computing. I didn't learn to code until after I'd done my PhD. I got a job in the oil industry. That is a place that makes tech look really diverse and inclusive. I wasn't particularly happy there. I was very frustrated in my job, and one day I was sat there, I was making slides, PowerPoint slides all day, and I was just like, I want a new challenge. I've tried to learn to code several times before and completely failed to do it, and I thought it just wasn't a thing that I could do. I thought I wasn't one of those people, but I was so bored that I decided to learn to code or anything. So I took a bunch of Python courses and eventually got to the point where I felt like, yes, I could write some Python. After that, I left the oil company and moved to the US I didn't have a job, didn't have a plan at that point. I ended up in Seattle and I was like, okay, I'm going to go find a geology job in Seattle. Nothing happened. Couldn't find anything. And this was sort of 2014, 2015. And I looked around and I was like, okay, what are there jobs in Seattle? Well, tech was the obvious answer. And LinkedIn started sending me notifications saying, hey, there's this data science job you might be interested in. I think I had science in my LinkedIn profile. And eventually I clicked on one of these and I was like, okay, that actually sounds pretty interesting. And then I knew that I had the data analytics skills from having done a science PhD, but I didn't really know much about machine learning. I needed to up my coding skills. So I spent 6 months or so taking all the online courses I could think of. And then what got me into actually having a job in data science was I did a project in early 2016 where I used a deep learning model. And then I also started networking. I went to some PyLadies events and eventually ended up with an internship at SAP Concur. And I was on a short-term work visa at that point, so I could get a full-time job, and they never asked me if I was still in school, so I was happy to be an intern for a bit. And that was a lot of fun. It was having deep learning on my skill set at that point that really helped me get into that. It was something at the time that made people kind of sit up and pay a bit of attention. So I worked there as an intern. I had to take another break for a little bit while I waited to get a green card and had proper US work permission. And then I went back to Concur and joined an innovation team. Part of my job there was to give talks and do thought leadership for the company. After one of these talks, I ended up getting an email from someone who'd seen the talk that I'd given on data privacy. And he was writing a book on putting machine learning into production and wanted to include a chapter on privacy. So he asked me if I was interested in writing this chapter. I ended up getting so interested in his book that we co-authored it together, and that came out in 2020. It's called Building Machine Learning Pipelines. Just putting together the second edition, just give you a minute. I continued at SAP Concur for a couple more years and moved into a team doing production NLP work. And then last summer, I decided to leave that and concentrate on writing my book full time. So I did that, I took a bit of sabbatical, and now I'm part-time consulting for a Gen AI startup, which is pretty fun.
Wow.
Yeah.
That's a lot. So I think one of the topic of your book is like software engineering.
Yes.
Why do you think software
when you first get into data science, you don't really feel like that's a different job. That's not what we need to do as data scientists. But I think there's three main reasons why it's useful to know more about that. So one of them is at the level of when you're writing code every day, because whenever you're doing data science, you're writing code. If you know more about what makes good code, then it's easier for you to reuse your code in the future. It's easier for other people to use your code. Your code is a little more efficient, and it's also more fun, because being able to do something well, being able to treat it as a craft is very satisfying. The second reason is to just help your code scale. So if you're writing code that touches a production system, it needs to be efficient, and it needs to not fall over and take the whole rest of the system down with it. And then another reason is to try and avoid technical debt. As data science becomes more mature, the data science code bases are more complex. If they're well engineered and they're modular, it's easier for people to use them. It's easier to reuse code in other places. And everyone can just get more data science done. Yeah.
So I guess, I don't know, I feel like you already answered this. Was that why you decided to write your book in the first place?
The reason I decided to write it was while I was working in the Concur Labs team, the innovation team, I was the only data scientist on the team. And I was working with a bunch of engineers and designers. And I found it hard to follow some of the conversations around what they were building. They'd say, oh yeah, we're just going to stand up this API. And I'd be like, wait, what's an API? And yeah. And then I started to look into this, but I like learning from books, and the books available had examples in Java or JavaScript, and they were aimed more at web developers, and that wasn't really relevant for what I was doing. And then as I got more senior, I started mentoring junior data scientists, and I realized that they had the exact same questions as me. They'd come out of a data science undergraduate or graduate degree, and they'd get into a technical job and they'd be like, oh, what's a test?
Yeah, I feel like it's pretty common, especially with people with software engineering backgrounds.
Yes,
like you
which is
and myself. I have a chemistry background.
probably most of us. Yeah. And yeah, I wanted to answer those questions in this book. What is a test? Why should I write a test? When should I use object-oriented programming? What is functional programming? How do I deploy things? What does it even mean when I deploy things? Yeah, so I thought this should be a book before I decided that I would be the one to write it.
Yeah, and then I guess this is more of a follow-up question.
Yeah.
Is your book more about applicable to Python, or is it also applicable to R, which I know is another common data science language?
It is completely in Python.
Okay, that makes sense.
Yeah.
Sorry for the R people.
Yeah, sorry. The principles are applicable to any language, but all the examples are in Python.
Yeah, that makes sense. I think I'm going to go back to what you were talking about with deployment specifically.
Yeah.
What are some common pitfalls you feel that people run into when deploying to production?
So I think if you're going to be talking about deployment in general, then I think it's not having a smooth process. So if you don't have a pipeline that can run automatically, then it's very hard to deploy things. There's a lot of friction. It means that you can't make quick changes if you find that there's something amiss with your code. I think that's very important, that once you set the deployment pipeline going, it runs start to end. Then it alerts you if there's problems with it, but that should be an automated fashion. It shouldn't be a manual, oh, I have to do lots of steps to get my code into production.
Is there anything specific to machine
Yeah, I think one thing is that there's this concept called training serving skew, which is where you can train a model, you can have some engineered features that go along with it, but then maybe you update the model, but you forget to update the feature engineering that goes with it. So suddenly your model performance declines in production and you're not quite sure why that's happened. The ideal would be to try and package both the model and the feature engineering together so that they can never be different versions. I think the other thing that's hard is monitoring in production and also closing the loop between having the model in production, getting feedback from your users, and actually plugging that into a new model.
Okay, so I feel like, oh yeah. So then, I guess, to reiterate what you said, it sounds like some of the ways we could avoid it would be like monitoring systems. How about, so I know this can often happen, especially like later on with machine learning models as they're deployed, their performance degrades over time.
Right.
What are some recommendations for that? There's situations where you may need to retrain,
Yes.
or you just maybe re-architect the model.
I think what you want to have here is some kind of automatic trigger that tells you it's time to retrain. So you're monitoring performance in production, and then you are monitoring the accuracy, and it dips below some particular level, and then that kicks off an automated training loop that goes around and selects and takes a new set of data, retrains the model, and then deploys that into production. Ideally with some, like, maybe you have some human feedback that's like a check on that, or it can be just completely automated if you're sure that everything's going to work properly.
Yeah. All right. Yes. Another question that was submitted by us, some attendees, was like, how do you believe ethical practices, especially those around privacy, will evolve in the ML field in the coming years? So I know that has become more of a concern, especially around like LLMs using like open source data, for example.
Totally, and this is top of mind for me right now because I'm working at a Gen AI startup. So, yeah. Honestly, I think that with privacy for machine learning in particular, it's becoming less of a data science problem and more of a product problem. And it's all about how your app and how your whole system is designed in the first place. Because once you've collected that data from your users, that is where the main controls on privacy happen. Not when it's already stored in your company's database and you're doing something with it. So I think it's more important to design privacy into your app from the first place and have consent from your users and be transparent about that process. What I think we do need to do as data scientists is become much more aware of security issues around machine learning. So security breaches are also a breach of privacy because your users' data gets exposed. And there's a lot of new avenues for security breaches with ML and with particular with Gen AI. So
yeah, I work in cybersecurity, and one of the things you can do is like red teaming or penetration testing.
Yes.
Where you're like testing models code.
yeah, and I think that's something that a lot of data scientists haven't even thought of as a thing at this point. But suddenly you need to not only produce the machine learning model that has some functionality in it and is accurate, but it needs to be resistant against attacks as well.
So I guess I'm gonna circle back a little bit.
Yeah.
You said right at the beginning, when you first started your journey of getting to data science as a field, what do you think people getting into data science should know?
So I think data science is really different now than it was when I was first considering it in 2015. And I'd be interested to hear people's opinions on this, but it seems to me like it might be, it's a good strategy when you're starting to pick a broad area of data science to get into. You can't learn it. You can't learn everything anymore. You can't be an expert in machine learning and analytics and data visualization and data engineering. You should pick, in data science specifically, it seems like a good idea to pick either the analytics end and go hard on the statistics, or pick the machine learning end and learn more software engineering skills, rather than trying to learn all the things.
So do you think then it makes more sense to maybe start in one and then branch out? Because I know a common thing that people will do is will maybe, for example, start data analytics, then move to data science.
Yeah, that seems like a really good way of doing it. And also with the job market being hard at the moment, then having skills in other fields than the data science as well is also useful. Do you want to do a couple more on the list and then we'll open it up to questions?
Yeah, sure. So we have a little bit of time. Here, how about so what did you learn? So I know you've obviously had a rich and different career, and a lot of it includes data science collaboration, especially among multiple teams.
Yep.
So what you learn about how to collaborate effectively with people with different backgrounds, and how has that impacted your work?
So I think one of the big impacts was that working with people who had a very software development background directly led to me writing a book, because I wanted to give people the language to interact with software developers. Like when I first started working with them, we weren't kind of talking about the same things. We needed to find a common language to what we wanted to work on.
Makes sense. I guess, do you want to open up to Q&A now?
Yeah, let's do that.
All right. Anyone in the audience who you want to choose?
Hi, Valerie Loptak. I'm an applied scientist at Amazon. And as an applied scientist, I deploy my own machine learning models. And I've been working on setting up a SOP for my group where standard operating procedures in our group for doing that. And as part of that, I've asked around Amazon developers to say, as a developer, what makes a code base seem reliable to you? What is a code base that if you look at it, you feel happy to take that on and own it? And I got a lot of different answers. I got people saying things about code coverage. I got people saying things about unit tests. I got people saying all kinds of things. But the only thing that was said that every dev in the table said, yeah, that's it, was if you look at the commits and you see recent one, you see that this code base is being actively developed.
That's such a great point. Yeah.
Yeah. So I'm wondering, from your perspective, you've done a study on this. What would you say is the marker of a reliable code base that you would want to own?
I think if I was looking at a data science code base specifically, I would want to see some tests. I often look at data science code bases and there are no tests at all. I would want to see code that is in shorter functions. I would want to see documentation. That's so huge. I would want to if I went to the code base, I would want to look at it and see that the README gave me instructions for how to use that project. Because then it shows that the person writing that code has put thought into how other people can use it.
Hi, I was wondering if you have a software engineering principle that you found that would be really valuable early on in your career, or early in your data science career.
Honestly, early on in my data science career, I didn't know very much about it.
Okay. I guess would there be a principle that you wish you would have known maybe?
So in my book, I broke this out into 5 main principles of what I think good code looks like. One of them is that your code is modular, so it's split into small pieces. It should be efficient, so it gets the job done within the time that's available. It should be robust, First chapter.
All right. Simplicity.
That's the one.
First one too.
Yeah, go for it.
Oh man, I have a new question now. A
Yeah.
really quick one. Are you a fan of Bob's Clean Code? Okay, that's fine.
I did read some of it, and I got really stuck on the introduction because apparently Bob only talked to guys.
Yeah, that's true. It just sounded like some of the things you were saying were echoing that. But
Yeah, it's definitely. I read a whole bunch of the software engineering literature and brought it together in one.
my real question though was, like, what do you see as the boundary between? So I'm a software engineer, and what do you see as like the boundary between data science and software engineering? Are there any topics that you try not to touch, that you really just trust your engineers? And like, what can we as engineers do to support the data science teams better?
I feel like the big difference is in the mindset, in that the data scientist is who you want to talk to if you don't know the outcome of your project and you want to run an experiment. And the engineer is who you talk to if you know exactly what you want to build and you want to build it. So I think data scientists can be great software engineers can be great data scientists, but it's a difference in what you're aiming to do with your projects is the main thing.
I'm curious about the boundary between like scientists that uses a lot of data and writes a lot of code and data scientists, and like how seemingly you've crossed that threshold, and like how someone knows like when they need to focus more on code reproducibility and things.
That's a great question. And I think it's, one of the things is like, if your code does everything you need it to do, and you can come back to it in 6 months, and you can pick it up again, and you're like, oh yeah, I know what I was doing, this all makes sense, you're probably good. But if you work on the project for a while, and you come back to it and you're like, oh, I have no idea what I was doing here, you might want to work on making that a bit easier to read. The other thing is that if you're working on something and you find that it gets hard to add new features to it, so you make a change and then something breaks in a different place, again, you might want to work on those skills.
All right. I think we are at